Okay, I'm going to move fairly quickly through these. First one, what is the correct way to set up to calculate 7 factorial? 7 times 6 times 5 times 4 times 3 times 2 times 1. What is the correct setup to calculate permutation of 8 things taken? Is that 3 or 2? 2. Okay, hard to read on here. So that would be 8p2 is 8 factorial over 8 minus 2 factorial, where the 8 minus 2 is in parentheses, factorial is outside. Okay. For arrangement to be a combination, the order of items doesn't matter. This thing's so. Find the number of ways to configure a 6-digit password with 2 letters followed by 4 digits. Okay, so the next few problems, there is more than one way to do some of them. For the most part, I'm going to show you the best way to do them, just to make sure you get it. They're not all combinations, they're not all permutations. It's kind of a mix. There's also the fundamental counting principle, which is what the first one is. So the first one, 6-digit password, 2 letters followed by 4 digits. So I have a 6-digit password. Okay. 2 letters, 26. 26, there are 26 letters of the alphabet. 4 digits, 10, 10, 10, and 10, and then you multiply that out. 676 followed by 1, 2, 3, 4 zeros. 6,760,000 different possible passwords. That's just 2 letters and 4 numbers. Still take a computer to break your code in about 10 seconds. Okay. Find the number of ways to have a president, vice president, treasurer for a field of 7. So the question you need to ask yourself, does order matter or not matter? Yeah, these are all different positions. Order matters. So this would be 7P, and then there's 1, 2, 3, 7P3. Yeah, here we go. And you get 210. Sorry about that. Number 6. Guys, thank you. So number 6, find the number of ways to select first, second, and third place winner from a drawing of 14 students. The implication first, second, and third have different values. So this one, once again, would be a permutation. So it'd be 14P3, which would be 2,184 different ways. How'd that happen? First, second, third, yeah. Find the number of 4-digit odd numbers. So 4-digit number. I have 1, 2, 3, 4 digits. The first one can be 9 because I cannot have a 0 in the first spot. I can have anything else. I can have anything in the second, anything in the third, and the last one I have 5 possibilities. 1, 3, 5, 7, 9. Multiply those out. 45 with 2 zeros. Number 8, find the number of ways 5 students could win a free limousine ride out of 125 students. Denny LeBron. Does it matter the order? Nah, 5 people win. Doesn't matter whether you're first or the 5th, you still get the same prize. So this would be a combination. 125, choosing 5 of them. 1, 2, 5. And there are a lot. 2, 3, 4, 5. 2, 3, 4, 5. 31275. 234,531,275 different ways of having winners. Okay. Number 9, find the number of different lunches. The deli offers 8 sandwiches, 5 drinks, 3 desserts. You assume each lunch consists of one of each. So the question is, how many times can you go there without eating the same thing twice? It's the number of sandwiches times the number of drinks times the number of desserts. That's what it is. 8 times 5 times 3, and 120 different days. You can go there 120 times without repeating your menu.
Oh, I don't want to do that. I find one thing and do it every time.
Depends. Okay, questions so far? Yes. Okay, so the idea behind number 7. Remember, you've got a number, 4 digits, 4,328, 1,201, something like that. 4-digit number, right? What can't I have in the first one? I can't have a 0. That's why it's 1 through 9. 1 through 9 for the first spot. I can't have 0 in the front because if a 0 in the front, it's no longer a 4-digit number. You get the rest of it? Okay. That's usually what screws people up. But then again, you got to remember the last one. And a lot of people don't think about 0. They only think, ooh, I have 9 options. What about 0? 0 gives you 10 possibilities. So you got to watch for that. Okay, right triangle trig. The ratio of side lengths for a tangent. Tripping on acid. Opposite over adjacent. Okay. The ratio of side lengths for a secant. Well, the secant is 1 over the cosine. Yes.
Would it be okay if you just had like O over A and instead for this one H over O?
I want to see at least that written out. I don't like the A over A. No, don't be that lazy.
Okay.
Don't be that lazy.
I learned trig that other morning.
I know.
So that's all I know.
Okay. So it's 1 over cosine, so it's the inverse of cosine. Cosine is cot, another hippie adjacent over the hypotenuse. The secant is the inverse of that, so the secant is the hypotenuse over the adjacent. It's the inverse of the cosine. And you have to remember which one's the inverse of the cosine, which one's the inverse of the secant or the sine. Okay? And the cotangent, that's an easy one. Cotangent's the inverse of the tangent. The secant, the cosecant could easily get screwed up. You have to have that memorized. Okay, use your calculator to find the secant of 35. The secant, once again, is 1 over the cosine. So the secant of 35 degrees is 1 over the cosine of 35 degrees. Yeah, that's how you have to type it in your calculator. 1, and you get 1.2207 or 08. Use your calculator to find the sine at 56 degrees. That's pretty easy to do. Sine 56.8290 to 4 decimal places. You can always go more decimal places. I am fine with that. 0.2903757. As long as you're accurate to the first 4, that's what counts. Going more means that you're accurate to the first 4. So going more is good. Going less is bad. Don't go less. If you ask for something specific, if I say 4 decimal places and you say that's 8.3, it's no bueno. It's not going to work. Follow the directions. Okay. Solve for x in the Triangles below. Round your answer to 2 decimal places. So this is where it gets a little difficult. I have 3 things involved. I have an angle and 2 sides. It works for both of them. What I need to do is my first step is to set up my trig ratio that involves that angle and the 2 sides. So I have this angle here, and the 2 sides I have is I have the hypotenuse, and then I have the one adjacent. So I think which trig function involves the adjacent and the hypotenuse? That would be the cosine. So the cosine of 52 degrees is equal to x over 14. Set up your cosine function or your sine function or your tangent function based upon the information you're given. Set this up first, then solve. Yes?
I've never really understood this. Oh, Jesus. I never really understood, like, how to find the stupid to the opposite side. Like,
Angle, side opposite.
well, but that one.
Opposite.
It's not the one
Okay.
that you have.
So I have an angle here. This side is adjacent. That's on the opposite side.
Oh,
The
so
hypotenuse,
it's the
it's
opposite.
always, yes.
Okay, so you just go through that.
Because yeah, your hypotenuse is always the longest side.
Yeah, I know that.
Opposite and adjacent are only in reference to which angle you're talking about. Because if I'm talking about this angle down here, they switch which one's which. I talk about this angle here. If I'm talking about theta, this is the opposite, and this one is the adjacent. If I'm talking about this angle down here, these two switch.
What would you ever have, like, 2 angles on those 2 corners? So, like, how would you?
You might. Then you have to decide which one you want to use.
Oh, you could just.
Yeah, just pick.
Would you use an inverse tangent?
Oh, we'll get to that. I mean, we'll get to that. Let's finish this one.
Okay.
I just wanted to address her concerns first. Let me finish
And
this
then
one.
on,
and we'll go.
on this one, do you multiply by 14?
Yeah, so yeah, you want to solve for x. Remember, the cosine of 52 degrees is just a numeric value. This would be like 3 equals x over 14. How would you solve for x? You multiply both sides by 14. So you get x equals 14 cosine of 52. So you take 14 times the cosine of 52 on your calculator, because you're not going to be like me and have to do it by hand. That's how I did when I was a kid, back in the old dark ages. 8.619. It says 2 decimal places, but if you give me 3, that's okay. Yeah, when I was a kid, I was the first kid in my school that had a calculator that could do sines, cosines, and tangents. Other than that, when I learned how, I used the table in the back of the books. Textbooks nowadays don't even have the tables in the backs anymore.
Did you have like a holster? Did you whip it out?
Yeah.
No?
No, I kept it in my backpack like everybody else.
I thought you said you were the first one.
That was the first one, yeah. I had the first one. Okay, so this one I have to do, I'm looking for theta, I'm looking for the angle. I still do the same first step. I still set up a trig ratio the same way. That's my first step. So I have an angle, and I have the side opposite and the side adjacent. Angle, opposite, and adjacent, no hypotenuse, that's the tangent. So the tangent of theta is equal to the side opposite or the adjacent, 21 over 13. So I always do that first. Now that I'm solving for the angle, now I switch it to the inverse function. How do I solve for the angle? Theta is equal to the inverse tangent of 21 over 13. And when you do this, make sure to put parentheses around the 21 over 13. And you get theta equals 58.240. This one, lessons. Okay. Questions? You know the ratios, it's strictly what do I have, what am I looking for, 3 things, they will get set up in a ratio in some way.
Oh, was it inverse tangent?
Okay. Set up the ratio. If you're solving for the angle, you'll need to use an inverse function. If you're not solving for the angle, just solve for the variable as part of the ratio. But you'll have 3 things, 2 sides and an angle. Set up one of the ratios, sine, cosine, or tangent. Do not mess with the cotangent or secant or cosecant. It's not worth it. Sine, cosine, and tangent are the only ones you want to use for these. Okay, for the triangle below, find cosine, tangent, and cosecant. State your answers in simplified radical form, no decimals. So the first thing I have to do before I can set up my ratios is I have to find, or I'm going to have to find that third side. I can get the cosine. Cosine of theta, this is the adjacent side. This is my hypotenuse. So I can get this. This is 5/8, not a problem. But I can't do the tangent because I need the side opposite. And I can't do the cosecant because I need the side opposite. So I have to find that first. So I set up 5 squared plus x squared equals 8 squared. Excuse me. 64. So x squared equals 39. X equals the square root of 39. Okay. So square root of 39. So the tangent, opposite over adjacent. Square root of 39 over 5. Okay. So cosecant is the inverse of the sine. The sine is the opposite over the hypotenuse. The cosecant would be the inverse of that, the hypotenuse over the opposite. Now, the rules say no decimals, and rationalize the denominator if necessary. I have a square root in my denominator. I'm not allowed to have square root in my denominator. To rationalize this, this is very easy. Multiply by root 39 over root 39. You get 8 root 39 over 39. Easy peasy. Any questions on this?